is came with this like north and like northwest and stuff. We did this with like vectors. That's like the very first thing we did in physics at the beginning of the year.
With vectors, yeah.
We do.
She didn't say different names and all that.
Well, because in trig it's called a bearing. Because it's an actual like direction a ship is going to take. I don't know how it's applied in physics.
Yeah, but we did that for you have. But we did like kind of what you did with like it travels this far going like northwest, but we did it with like 6 different ones. So like it was like
Yes, yeah, like crazy.
it's not as fun.
Not as fun. Glad the trig part could be a little better than the physics part then. The homework from last night was a worksheet with 7 questions on it. I am going to thoroughly like look at that, not necessarily grade, because I'm still looking at it as a completion. But I wanted to give you feedback on it and correct any diagrams that might be drawn incorrectly. So please make sure when you get the notification from me that you check any problems that might need reworking so that you can kind of see how to correctly label those triangles and diagrams. So I will physically be like correcting them instead of just typing in a comment, actually correcting the diagrams. Today is a 9th period full of fun Friday. It's actually full of a lot of concepts that we're going to talk about. Inverse trig functions. So we got a lot to do for a Friday 9th period. Hopefully you're still all up for the challenge. Lots of stuff. It's a big Friday. We're going to talk about inverse functions. So we're going to go directly into the notes. Our goal is to kind of look at a graph and see what the inverse of the graph would be. And then also try and evaluate this inverse trig function. And there are only 3. So there's one for sine, one for cosine, and one for tangent. The reciprocals don't get inverse functions because they're just reciprocals of the sine, cosine, and tangent. So in your packet, this is the last section we're looking at, page 55. And before we get to the notes, I just want to give you a little inverse refresher with algebra functions. You do not need to write this down, but this is so that you kind of think about the process in your brain to review what an inverse function looks like or how to find one or when one exists. So if I go back to the most, you know what, they're not allowed in. I don't feel like walking over there anymore. Who is it? Yeah, I think next week we're not going to let them in if they're late. I'm already talking. I'm going. All right, thank you. I appreciate you letting me know. So if you take the function just y equals x squared. Daniel, what kind of function is y equals x squared? What's that? Yeah. Parabolic function, parabola. Parabolic sounds much better though. So again, just to get you kind of into the thought process, a parabola is a U, something like this. So when we talked about these in chapter 1, which was September, October-ish, you also talked about them last year in chapter 6, which we just finished today, taking a test on Monday in Honors Algebra 2. Some functions do not have inverses. Not every function has an inverse. Does anybody remember the test that you can do to a graph, like this parabola, to decide if it has an inverse, Daniel? So the vertical line test says it's a function, but what decides if it has an inverse?
It will have an inverse if it has
the horizontal line test. So it has an inverse if it passes the horizontal line test. Well, to pass the horizontal line test, it can only pass through the graph once. So does a parabola have an inverse? No. But math people Don't let things go with a simple no. They force functions to have inverses because if we said simply no, there is not an inverse, then a lot of functions actually wouldn't have inverses. So what we do is we say, all right, well, I have this parabolic shape. It doesn't have an inverse, but if I restrict x and say x must be greater than or equal to 0, then we are looking at the side of the graph where all the x values are greater than or equal to 0. The other side of the graph doesn't exist anymore. So if I delete part of the graph, now does this graph have an inverse? Yes. It has the same shape of a parabola, but we're only looking at a piece of it. And that's what we're going to do today. Because a sine wave goes up and down, up and down. We usually graph 2 periods. And if you look at a sine or think about a sine in your head, that would never pass the horizontal line test because it's going to continue to cross through the waves a whole bunch of times. So we will be deleting part of the graph so that a section of the graph has an inverse. So it won't be the whole graph. So that's the goal. Before we get to that, just a couple of things about the way you will see an inverse function written. So when you're finding an inverse in trig, you're actually finding an angle. And in this case, I just chose to say sine. So an inverse means you're finding the angle whose sine is x. So if I have the sine being equal to 1/2, I'm finding the angle when the sine is 1/2 on the unit circle. So we're going back to the unit circle and wrapping up with the unit circle again. So inverse functions in trig are finding the angle. When you press the inverse button on your calculator, you're finding the angle, like number 4 in your homework last night. So number 4 on this page as well, if I'm finding the inverse using the calculator, I would literally just tap that sine -1 button. And that answer is an angle. There are 3 different ways that you could see the notation for an inverse function. And the first notation uses a special trig prefix called arc, A-R-C. And then if the word or the function sine follows it, then I have an inverse function. So y equals arc sine of x is really a way of saying y equals the inverse of x. Or I want to find the angle whose sine is x. So that arc part is a trig term, a trig word that you use with trig functions. You may also see it, and you're going to see the book writing it both ways. You may also just see the actual inverse notation with the sine -1. Remember that little -1 is the inverse notation for any function that has an inverse. F -1 is what we usually use, but in this case, we have the inverse for sine. And then the last way is more just on the definition of an inverse function. An inverse is found by switching x and y. So I could also say x equals the sine y, and that would represent the inverse function because I would switch x and y. The first 2 are the way you're going to see it written in the book. And the problems you see today will say arc sine or sine -1. So that's what we'll be looking at. So to start this little sine inverse, because we're going to do each function on its own, we're going to graph the regular sine equation. Just like we've been graphing, we're going to label the x-axis from -2 pi to +2 pi, the y-axis going up to 2 and down to 2. And we're going to do a really quick sketch here of sine. So again, the y-axis is the whole numbers. The x-axis would be that pi over 2, pi, 3 pi over 2, 2 pi. And we're just going quick here, a little quick graph. It's not going to be the prettiest graph. So sine starts at what point? What's the first point of sine? Think about what sine looks like. Sadie?
0, 0.
Excellent, 0, 0. So sine starts at 0, 0. It goes up, goes back in the middle, all the way down, and then ends back in the middle. So remember, sine is the curve, the wave that goes up and down, up and down. And in the other direction, it goes the exact opposite. So now I have my sine wave, up, down, up, down, up, down, and so on. So that's a sine graph. We already answered the first two questions underneath. Daniel answered them for us. What test must a relation pass in order for it to be a function, Daniel?
It needs to pass the vertical line.
Yep, vertical line test. So any graph, if it passes the vertical line test, it's a function. We have been graphing the function sine for a long time, and we've called it a function. It passes the vertical line test. What test must a function pass in order for the function to have an inverse, Daniel? The horizontal line test. And we already said that this graph would not pass the horizontal line test. I mean, it's going to cross through a whole bunch of times horizontally. So mathematicians limit the domain of the sine wave in order to force it to have an inverse. The way that is done is if you go to your graph. A cycle starts at 0. The unit circle starts at 0. So when you have an inverse function, it's going to start at the origin. Graphs work from left to right. So if I start at the origin and move to the right, I'm going to just trace my graph as far as I can until it would no longer pass the horizontal line test. And that would be at pi over 2. Because if I pass pi over 2 and I go down the curve, it doesn't pass the horizontal line test. So from 0 to pi over 2, that piece there would pass the horizontal line test. But I could still have more to the inverse, because if I go back to 0 and continue in the negative direction, I can get more of the graph by continuing down to -1 or negative pi over 2. So essentially, starting in the middle, get as much as you can of the graph until it fails the horizontal line test. That's where your inverse exists. So I'm going to cross off, cancel the rest of it. And now I have the inverse piece that would exist. Just like the parabola. We deleted the one side, we had the piece on the other side that would have an inverse. So this piece has an inverse. None of the rest does. It only exists between these values. Questions? So what we're going to do is we're going to graph the inverse function. This isn't the inverse function. This is still sine. It's just a piece of sine. We want to graph the inverse function. And to graph the inverse function, we're going to take the original ordered pairs. So I have an ordered pair at negative pi over 2 and negative 1. Sadie said it started at 0, 0, and then we have a point at pi over 2 and 1. How can you find the inverse by using 3 ordered pairs? What would you do with those ordered pairs to find an inverse? Think about what it means to have an inverse. Yeah, you just switch x and y. That's what an inverse is. God bless you. An inverse switches x and y. So for our inverse function, literally, we're going to switch x and y. So for the inverse, I now have a point at -1, negative pi over 2. 0, 0 doesn't really switch. And then +1, pi over 2. If your x and y switch, when you label your x and your y axis, that has to switch too. Because my y values are now pi over 2 and negative pi over 2. My x values are now 1 and -1. So if you're switching x and y to get an inverse, then the axes, when you label them, must switch as well. So We're going to plot the 3 new points that we have found by literally switching x and y. We now have a point at -1 and -π/2. We have a point at 0, 0, and we have a point at +1, +π/2. Now, I can't connect these with a straight line because the cosine graph, the sine graph is not a straight line. It's a curve or a wave. When you have a function and its inverse, they're reflections of each other over y equals x. So when we make our inverse function, it needs to be a reflection of the current graph, which means it has to flip. So my graph is going to flip or be the reflection of the original graph. So this bottom half, the curve, has to go in the opposite direction. It needs to bank kind of like outward instead of inward. The top half, the curve, needs to go in the opposite direction. So inverse functions, if I have a function and its inverse, the 2 graphs should be a reflection of each other over the line y equals x. Questions on any of that? So Zach, answering the questions below, what is the domain of this inverse graph? And the range of the inverse graph is? Nice job. The next 2 questions say, what is the domain of sine and what is the domain or the range of sine? Well, the domain of sine that we used was from -π/2 to +π/2. Yes, I know it goes on forever, but for the inverse to exist, we're only using -π/2 to +π/2. The range of sine is from -1 to 1, because the lowest point is -1, the highest point is +1 in my sine graph. If you look at those pairs of solution, the domain, whoops, I connected the wrong one there. The domain of the inverse is the range of the function, or I could flip that. The range of the function becomes the domain of the inverse. Daniel.
I'm wondering if on the last 2, are those going to be brackets or parentheses?
They're meant to be brackets. Yep. They kind of look sloppy, huh? Yeah, these guys are brackets. And the reason they're brackets is because that point is a point in the graph and it is included. So that's as far as I can go. So the domain of one always becomes the range of the other. The range of one always becomes the domain of the other because we're switching x and y. So now you know how a function has an inverse and how it's created, but we have to be able to apply that as well. Your homework tonight, the first group of problems are 5 to 13, all but only part A, because there's a part A and B. That homework will look similar to the 3 problems that we're going to go over right now. So it says, evaluate the inverse sine function. Find the values for the following if possible. And then, I like this part, do not use a calculator. So you should have no decimal answers. They should all be exact. There are a couple of questions here. No, you won't have to write an actual sentence for some of these, but we are going to have a little bit of work. It's minimal work. It's more of a thought process than anything else. So the first part here says, what should you think? Because this notation looks weird. What the heck are we trying to find? So we have arc sine -1/2. We're really finding the angle whose sine is -1/2. That's what that means. So we're trying to find the angle whose sine is -1/2. Again, you don't have to write that in your homework tonight, but that's what you're trying to find when you're finding an inverse. We're trying to find the angle. You do need to write an equation. So we're going to take this inverse notation and write it as an equation that we would have seen during the first half of the chapter. We are trying to find an angle for a sine value. So that means I have the sine of an angle. That angle is supposed to be equal to -1/2. This equation is something that we've worked with back in sections 4.2, 4.3, and 4.4. So that equation, the angle whose sine is x, sine theta equals -1/2. Now the next part, it says think some more. We're not actually going to write a sentence. We're going to draw the diagram. So we're going back to the unit circle. So I'm going to draw an XY axis. There's my lovely XY axis. Little reminder, pi over 2 is at the top. This is 3 pi over 2 or negative pi over 2 at the bottom. Here's where it changes a little bit because we're finding the inverse function. The inverse for sine only exists from negative pi over 2 to positive pi over 2. That means that pi doesn't exist, or any number on the left side doesn't exist, because any number past pi over 2 will not exist. So that whole left side doesn't have an inverse, because the inverse only goes between those two angles, negative pi over 2 and positive pi over 2. So here's where you have to think back to the unit circle. Gabby, on the unit circle, the sign was either the x or the y of the ordered pair. Do you remember which one it was?
The Y.
The y. So sine is y. So that means in my ordered pair, the sine is -1/2, or the y is -1/2. Gabby, if you have a y value at -1/2, what would your x be of that ordered pair?
It would be positive square root of 3/2.
Yeah, positive square root of 3/2. Between the first and the fourth quadrant would be where my angle is located. If y is negative, Zach, is it going to be in the first or the fourth quadrant? If y is negative, it's going to be in the fourth. So we need to find an angle in the fourth quadrant. It's in the fourth quadrant because my y is negative, when the sine is equal to -1/2. So what family of angles would have a sine of -1/2 or positive 1/2, or would have an ordered pair of the square root of 3/2 and 1/2? So think about that family of angles. What has that ordered pair? So we had this is pi over 3, the pi over 6, the pi over 4, pi over 6. So as I said, it's more of like a thought process, thinking about the location of your angle and going back to the unit circle. Now, if this has to be in the fourth quadrant, my pi over 6 angle has to be negative, because then I'm going into the fourth quadrant by having a negative angle. So an inverse trig function is an angle when you're given a value for sine, cosine, or tangent. But that angle can only be located in one quadrant, because it's positive in one, negative in the other, and the other half doesn't exist because there isn't a function that exists over there. Questions? Anybody at home have questions? All right, so we're going to work through it again. It'll be a little quicker, so now they kind of see what we're trying to do. Notice the notation is the other way, and you're going to see both ways written tonight or whenever you look at your homework. Sine -1, √3/2. So the inverse sine at √3/2. What should you think? Well, we're really finding the angle whose sine is √3/2. That's what that really means. So the biggest thing that I need you to get in your brain is that we're finding angles. That's really what that notation means. Cassidy, how would you write an equation for inverse sine √3/2? Yeah, and that is actually part of your work. I need to see that equation. So flipping it into an actual equation form. And then the next part, draw yourself an XY axis. You will always cross off the second and third quadrant if you're finding the inverse sign, because it only goes from negative pi over 2 to positive pi over 2. And then you just need to think about the sign being y and the matching x value. So Daniel, if sine is y and it's root 3 over 2, what would the x value be with root 3 over 2?
In that case, it would be 1/2.
Yeah. This is a positive y, so a positive y is in the first quadrant. If it's negative, it's in the fourth. It's only one or the other, because the other two aren't part of the inverse. So Daniel, what angle has an ordered pair at 1/2 in root 3 over 2?
That's pi over
Pi over 6. There you go. Pi over what? The last one was pi over 6 because it was root 3 over 2 and 1/2. So what's the other option? Because this is the flip.
Wait, so that's pi over 3?
There you go. That's pi over 3.
Yeah, I must have misspoken. I meant to say it was if the x is
So if the x is 1/2,
1/2, then that's the longer one. So what
So
would
the-
be as far out as 60 degrees?
correct.
So it would be 30 degrees. So it wouldn't be pi over 3.
This is the longer one, so it has to go up higher.
Oh, I'm sorry. I missed something.
No, you're good. I think you're confusing yourself. I think you know what it is. So your angle would be pi over 3. So questions with that? All right, there's one more here. Again, the other notation, inverse sine of 2. We are really finding the angle to sine is 2. So Sadie, our equation would really look like,
Sine theta equals
yeah. And then it says comment. Apparently we're supposed to make a comment here about what this is going to mean, what's going on here. So remember, you're trying to find an angle when the sine value is 2. Sine, we said, was y. Think about this. That's why there's a comment there. The ordered pairs on the unit circle. Is there ever a y value on the unit circle of 2? Is y ever 2 on the unit circle? No. Because the range of sine goes from -1 to +1. When you graph sine, the highest point is at 1, the lowest point is at -1. So can you find a sine value that's equal to 2? No. So my little comment here, the range is -1 to +1. So this is undefined. I know, Daniel, you just took out your calculator. Did you plug this in your calculator?
Yeah, it just gave me.
It gives you an error. You can try it in your calculator. It will say error because it doesn't exist. And that's the calculator's way of saying, nope, can't do it. Doesn't exist. So anytime the value is bigger than 1, it does not have an inverse because it must go between 1 and -1. So there's a couple restrictions on these. You have to restrict your angle, but then the number that it's equal to has to also be between 1 and -1. Questions? All right, so we got 10 minutes. We have 2 more inverses to do, and I just spent the first 25 on the first inverse. So we're going to fly through the next 2 because you know kind of what we're looking at now. So if you scroll down, we're going to graph cosine, and we're going to graph its inverse, just like we did with sine. So now that you've seen how it's done once, it should go a little quicker with cosine. Label your graph the same way. So pi over 2, pi, 3 pi over 2, 2 pi. Y-axis is up 1, up 2. Cosine starts up high. Sine is the one that starts in the middle. So when you go to graph cosine, remember that first point is up at positive 1 on the y-axis. And then it goes all the way down and comes back up. And it does the same thing on the other side because cosine is even. So underneath, we know the answers to the next 2 questions. Still has to pass the vertical line test. Still has to pass the horizontal line test. Where do you think the inverse would be located? What would we restrict on this graph, Daniel?
It would have to be between 0 and pi.
Yeah, so starting at 0, moving forward to the right until it no longer passes the horizontal line test. And that would end at the value of pi. So he's saying from 0 to pi. And again, they get brackets because they're points on the graph. And I'm going to delete the rest of it. So our cosine graph now only exists from 0 to pi for the inverse to exist as well. Questions on that? So the next thing we're going to do is just like we did with sine, we're going to graph the inverse. And we did that by making ordered pairs for sine. So make ordered pairs for cosine, starting at 0, 1, at pi over 2, 0, and then at pi, negative 1. Flip-flop those ordered pairs, and those are the ordered pairs for your inverse. So now 1, 0, 0 pi over 2, and negative 1 pi. So taking the 3 ordered pairs, flipping them to get our inverses ordered pairs. Remember, the y-axis now would be the location of your angles because the y values are angles. So I have the angle at pi over 2. We have the angle at pi. My x-axis is my integers. And then I'm going to plot the 3 points. So my graph should be a reflection of the original graph. So if you look at your original graph, reflect it or make it do its opposite. So it should be a reflection over y equals x. So it's still a decreasing function, but the direction of the curve is different. So it still decreases because it's decreasing from 0 to pi. So it still is decreasing. Any questions with finding the inverse graph for cosine? So if you answer the questions underneath, Cassidy, the domain of this inverse function is, which is the same as sine. They have the same domain for the inverse function. How about the range of this, Cassidy? Yeah, it's from 0 to pi. That's different than sine. Sine is negative pi over 2 to pi over 2. Cosine starts at 0 and it just moves forward to pi. Looking at the bottom 2 questions, the domain of the cosine that we used was 0 to pi. And the range was from negative 1 to 1. So again, the domain becomes the range the range becomes the domain. So there's a relation, a direct relation from one function to the next. The most important part here is that restriction. So when you go to find your angles for cosine, they have to be between 0 and pi. That's the only location the angles can exist. All right, one more function, and that's our tangent function. Tangent is the function that has vertical asymptotes. We're only going to graph a little section of tangent. So we have pi over 2. I'm just going to go up to pi. Tangent is an increasing function with asymptotes. The asymptotes for tangent are at negative pi over 2. Use my fancy new button here. There we go. Negative pi over 2 and positive pi over 2. That's where our asymptotes are located. So tangent has asymptotes, unlike sine and cosine. There are numbers that can't exist for tangent. In the middle of those asymptotes is what? What's directly in the center? The x-intercept. And then it goes up because it's increasing from left to right. So if I continue this, I would have a repeat of my graph. And if I start repeating it, it's no longer going to pass the horizontal line test. So this graph drawn is one period of tangent, but it's also the location for our inverse function. There are parentheses around there because there are asymptotes. It's the one that does have parentheses because there are not points to end the graph. So when we go to flip this, if it was a vertical asymptote, what do you think it's going to become? Horizontal. So my vertical asymptote was x equals, now it has a horizontal asymptote. So this graph still goes up to pi over 2 and down to negative pi over 2. But the asymptote that was at negative pi over 2 for x is now at negative pi over 2 for y. And again, if it was at pi over 2 for x, it's now at negative pi over 2 or positive pi over 2 for y. So flipping or finding the inverse also means switching the direction of the asymptotes. Sadie said there was an intercept at 0, 0. There's still an intercept at 0, 0. And then you need to reflect your graph. So now it's still going to increase, but it's moving left and right. So still an increasing function moving left and right. So the domain, look at your graph. What's the domain? It goes on forever. It's not stopping. This domain is negative infinity to positive infinity. The range is between our two asymptotes. And again, that range is really important when you're finding the angles. I said it was a big day of notes for a Friday. That's a lot for a Friday, right? Especially ninth period. Your homework tonight will look similar to these 3 problems that we did when you're finding the angles. You'll have to use the unit circle. And then there's a whole group of problems just using the calculator. So if it says use the calculator, use the calculator. Any questions? So we'll do more of this on Monday. We'll wrap it up on Tuesday, review both word problems and inverses on Wednesday, and take a little test on Thursday. And then everybody gets to come to school on Monday, March 1st. And if you didn't get that email, get it. Make sure mom or dad or parent or guardian submits a form for each of you in your family. Have a fantastic weekend. Everybody at home, have a great weekend.
Have a good weekend.
Have a
Thank
nice
you,
weekend.
Tawana. You too, Maya.